Can numbers and equations answer the biggest question of all? We live in a world ruled by math. Math builds our cities. Math sends rockets into space. Math predicts eclipses, weather, and even the behavior of tiny particles. So it feels natural to ask, if math is this powerful, can it also answer the question, does God exist? Many people today believe that math and science have already settled this question. Some say if God were real, math would have proven it by now. Others believe equations and logic leave no room for a creator. This belief is becoming very common, especially in modern discussions, online debates, and scientific circles. But here's something important. This video is not a debate. It's not an argument against atheists, and it's not an attempt to mock science or reason. In fact, it's the opposite. This is a calm and thoughtful exploration of what math actually does and what it cannot do. Because before we ask whether math can disprove a creator, we need to ask a more basic question. Is God even the kind of thing math can talk about? The goal here is not to force belief. Belief cannot be forced by numbers or words. The goal is much simpler and much more honest. To expose a common misunderstanding. A misunderstanding about math, about science, and about the limits of human tools. If math is a tool, then like all tools, it has boundaries. And sometimes the biggest mistakes happen when we ask a tool to do something it was never designed to do. So let's slow down, let's think carefully, and let's explore step by step why math, for all its power, may not be able to disprove a creator at all.
Before we talk about what math cannot do, we need to clearly understand what math actually is. Math is a tool, a very powerful tool, but still a tool. At its core, math works inside rules, definitions, and assumptions. We define numbers, we define operations, we agree on axioms, basic starting points, and then build logic on top of them. Once those rules are accepted, math works beautifully. This is why math is so reliable. We use math to build bridges that don't collapse. We use math to predict the motion of planets. We use math to calculate speed, distance, and time. We use it to recognize patterns in nature, in music, and in technology. When something follows a pattern, math can describe it. When something obeys rules, math can model it. But here's the important part, and this is where many people get confused. Math does not create reality. It doesn't bring things into existence. It doesn't decide what exists. It only describes how things behave once they exist. Think about it this way. The equation for gravity did not create gravity. The formula for motion did not create movement. The math describing a circle did not create the circle. Math discovered patterns that were already there. So math is like a language, a very precise language, but still a language. It tells us how things behave. It tells us how things interact. It tells us how systems respond under certain conditions. But it does not tell us why those things exist in the first place. This leads us to a key idea that's often overlooked. Math explains behavior, not existence. It can tell us how matter moves, but not why matter exists. It can describe the universe with equations, but not explain why there is a universe at all. Understanding this distinction is crucial, because if math is only a descriptive tool, then expecting it to disprove a creator may already be asking too much from it. And this brings us naturally to the next question. If math describes reality, what are the limits of what it can describe? Now that we understand what math is, we can talk about something even more important. What math can talk about and what it cannot. Math is excellent at studying certain kinds of things. It studies quantities, how much of something there is. It studies structures, how parts are arranged together. It studies relationships, how things affect one another. And it studies patterns, what repeats, what changes, and how. Whenever something can be counted, measured, or modeled, math becomes incredibly powerful. That's why math works so well in physics, engineering, and technology. But there are things math does not study directly. Math does not measure meaning. It does not calculate purpose. It does not assign moral value. It does not explain conscious experience, what it feels like to be aware. And most importantly, math does not explain existence itself. To see why this matters, think about a simple analogy. A ruler is designed to measure length.
A thermometer is designed to measure temperature. Both are useful tools. Both are accurate within their purpose. But no matter how advanced a ruler becomes, it will never measure love. And no matter how precise a thermometer becomes, it will never measure purpose. Not because love or purpose are unreal, but because those tools were never designed for that task. Math works the same way. It measures structure, quantity, and behavior. It does not measure meaning, intention, or ultimate cause. So, when someone says math has disproven God, we need to pause and ask a very simple question. Is God even the kind of thing math is meant to test? Because if God is understood as the source of reality, the reason anything exists at all, then God is not a number, not a pattern inside the universe, and not a measurable object within space and time. And that leads us to a crucial realization. Before asking whether math can disprove God, we must first ask, is God even the kind of thing math can talk about?
At this point, we can address the core mistake behind many claims that math can disprove God. To do that, we first need a neutral definition of what people usually mean by God. Across philosophy and theology, God is commonly understood as the creator of space, time, matter, and the laws that govern them. This definition is important because it already tells us something critical. If God is the creator of space and time, then God is not located inside space and time. If God is the source of matter and physical laws, then God is not made of matter and does not obey physical equations. This leads us to a logical problem many people overlook: a category error. A category error happens when we apply the wrong kind of tool to the wrong kind of thing. Numbers exist inside the universe. Equations describe relationships within reality. Math operates on systems that already exist. But God, by definition, is claimed to exist before and beyond the universe. So trying to analyze God using math is like trying to study the author of a book by examining the grammar inside the story. Or think of it this way. You can study a video game's rules. You can analyze its physics engine. You can even predict how characters move inside the game. But none of that tells you who created the game. The rules of the game don't explain the programmer. In the same way, the laws of the universe, no matter how mathematically beautiful, do not explain the source of those laws. This is why math, powerful as it is, may be aimed at the wrong target. And this brings us to a key insight. Trying to disprove God with math is like trying to weigh a thought on a scale. A scale is excellent at measuring weight. It is useless for measuring ideas. Not because ideas are imaginary, but because the tool is not designed for that kind of reality. So if God is not a mathematical object, not a physical thing, and not part of the universe's internal structure, then math cannot directly confirm or deny God's existence. This doesn't prove God exists, but it does show something very important. The claim that math has disproven God rests on a misunderstanding of what math can actually test. And this naturally leads us to the next question. Even if math cannot test God directly, can it at least prove that God does not exist?
Now we arrive at one of the most important ideas in this entire discussion. This section is not about belief, it's about basic logic. There is a very simple principle in reasoning that many people overlook. Proving that something exists is much easier than proving that something does not exist. To prove that something exists, you only need one clear example. But to prove that something does not exist, you need complete knowledge. Let's make this very simple. If you claim that black swans exist, you only need to find one black swan. One example is enough. But if you claim that black swans do not exist, you would have to search every river, every lake, every corner of the world. If you miss even one place, your conclusion could be wrong. So existence requires one observation. Non-existence requires total certainty. This difference is small, but it's extremely powerful. Now let's apply this idea to the question of God. When someone says math has proven that God does not exist, they are making a very strong claim. For math to prove that God does not exist, it would need to rule out every possible way God could exist. That means math would need access to all possible realities, all possible universes, all forms of existence, all ways reality could be structured. But math does not work like that. Math works inside models. A model is a simplified representation of reality. It starts with assumptions, definitions, and rules. Math can tell us what follows if those assumptions are true, but it cannot tell us that those assumptions describe everything that exists. And this is the key point. If God is not bound to space, time, or physical laws, then God is not bound to any mathematical model of the universe. No matter how advanced our equations become, they only describe the structure within reality, not everything that could exist beyond it. So, when someone claims that math has disproven God, what they are really saying is, within my model of reality, I don't see God. But not seeing something inside a model is not the same as proving it does not exist. This is why the claim fails logically. Math is incredibly powerful. It has transformed human knowledge, but it cannot rule out what lies beyond the boundaries of its own models. And that leads us to a calm and honest conclusion. Math is powerful, but it cannot rule out what lies beyond its reach.
Let's take a step back and look at something truly simple, but also deeply profound. The universe exists. It's right here, right now, all around us. Galaxies, stars, planets, life, and even ourselves. It's a fact so obvious that we almost forget to ask the questions it raises. Questions like, why does anything exist at all? Why do these particular laws govern the universe? Why this universe and not nothing? These are not abstract curiosities. They are the very foundation of philosophy, science, and reason. And here's the point. Math can describe the universe beautifully. Equations can tell us how planets orbit. Formulas can predict the behavior of light, atoms, and energy. But math only works after something exists. It describes the universe once it's already here. It cannot tell us why there is a universe in the first place. This is where the idea of a cause beyond math comes in. If the universe itself needs explanation, its existence, its laws, its order, then the explanation cannot be just numbers or formulas. A creator, by definition, is not a math equation. A creator is not something that follows patterns inside the universe. A creator is the reason why equations, patterns, and laws exist at all. This is not a leap of faith. It is reasoning based on cause and effect. We see the universe, we see its laws and order, and we ask a simple, honest question. Why is there something rather than nothing? This question moves us beyond the limitations of math. It points to something that exists before models, equations, and observations. And while this does not provide proof in the emotional sense, it is a logical and rational conclusion. The universe itself raises the question of a cause beyond what math can describe. At this point, it's natural for some questions or objections to arise. Addressing them calmly increases both clarity and fairness. Objection 1. Science will explain everything someday. We just don't know enough yet. It's true that science has explained many amazing things. It predicts the motion of planets, the behavior of atoms, and even the evolution of life. But here is the important distinction. Science explains processes, not purpose. Science can tell us how things happen. It can show us the mechanisms behind the universe. But it does not explain why there is a universe at all, or why there are laws that govern it. Even if science were complete, even if we knew every particle and force, it would not answer the question, why does anything exist rather than nothing? Objection 2. Maybe the universe created itself. Maybe it just sprang into existence. This idea is logically problematic. For anything to create itself, it would have to exist before it existed. That is a contradiction. Something cannot be its own cause. Logically, something must exist prior to the effect in order to bring it about. This is why the notion of a universe that creates itself fails as a complete explanation. Objection 3. God is just a gap in knowledge. We use God when we don't understand something. This is a common misunderstanding. God is not simply an explanation for ignorance. God is not a placeholder for what we don't yet know. Rather, God is proposed as the reason why anything exists at all, the explanation for existence itself, not a temporary unknown.
Math, science, and philosophy may describe the universe, but the question of why there is something rather than nothing points to something beyond these descriptions. By calmly addressing these objections, we see a pattern. Many arguments against God rely on either misunderstanding the limits of math and science or confusing existence itself with observable processes. Recognizing these limits is not a denial of reason or intelligence. It is simply acknowledging that some questions may require tools beyond math and empirical science. And with that understanding, we can move to the final reflection: what this all means for belief, doubt, and human understanding.
At this point, it's important to pause and consider what all of this means for belief and doubt. Doubt is natural. It is a part of being human. Questioning, wondering, and seeking understanding, these are signs of curiosity and intelligence, not weakness. Belief in God is not anti-intellectual. Many of the greatest thinkers in history have explored God through reason, math, and philosophy. Belief can coexist with careful thought and critical inquiry. At the same time, disbelief is also a philosophical position. Choosing not to believe, questioning the claims of religion, and demanding evidence, these are legitimate approaches to the question as well. The key is balance. Math does not force belief. It cannot provide certainty for or against God. At the same time, math also does not justify certainty in disbelief. Just because a number, equation, or model exists does not prove the absence of a creator. In other words, both belief and disbelief involve a recognition of limits, the limits of our tools, our knowledge, and our understanding of reality. And sometimes, wisdom is found not in certainty, but in acknowledging those limits. Sometimes, wisdom is knowing the limits of our tools. Recognizing that math cannot answer every question does not weaken reason, it strengthens it, by helping us ask the right questions, and by showing us where our tools can guide us and where they cannot. This understanding prepares us for a final reflection: how to think about God, existence, and the universe with clarity, calm, and reason. As we come to the end of this discussion, let's take a moment to restate the core message. Math cannot disprove God, not because God is hidden or because the question is unimportant, but because God is not a mathematical object. God is not a number, an equation, or a pattern inside the universe. God, as understood in philosophy and theology, exists beyond the scope of math itself. This is not a call for belief. It is not a demand for agreement. It is an invitation to reflect. Think about the limits of the tools we use every day. Think about what questions they can answer and what questions they cannot. Some questions are larger than equations. Some answers lie beyond proofs and calculations. Some truths require more than tools. They require reflection, reason, and sometimes wonder. So, as you leave this discussion, remember this: the greatest questions may require more than numbers. And in that realization, there is room for curiosity, humility, and thought, the very qualities that make philosophy, math, and science meaningful in the first place.
If this discussion has made you pause, reflect, or ask new questions, take a moment to think about them. I'd love to hear your thoughts. Please share them respectfully in the comments. Curiosity and calm reflection help us all learn. And if you want more videos like this, exploring philosophy, science, and the biggest questions in life, consider subscribing. Let's continue thinking together, thoughtfully, calmly, and curiously.